In this episode, we move into a topic that feels modern and technical very quickly, but the core security problem is actually very familiar once you strip away the excitement around new tools. Artificial intelligence, AI, systems are only useful because data moves into them, through them, and sometimes back out of them in forms that people or other systems can use. That movement is what we mean by a data pathway, and it matters because security risk often hides in motion more than in storage alone. A team may focus on whether the AI model is powerful, accurate, or convenient, but security has to ask what information enters the system, where it travels, what other services it touches, who can access the results, and whether any part of that path crosses boundaries that should be tighter. Once you start seeing AI as a set of connected pathways rather than as one magical box, segmentation, zero trust, and protected environments become much easier to understand and much more obviously necessary. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. A useful starting point is the simple idea that an AI system rarely works in isolation. It usually depends on prompts, files, messages, databases, application connections, user identities, storage locations, and supporting services that help it retrieve information or deliver outputs. Even a basic assistant feature may involve several steps behind the scenes, such as receiving a user request, drawing in contextual information, processing the content, generating an answer, and then saving or transmitting some part of that result to another location. Each of those steps creates a point where sensitive information might be exposed, changed, copied, or reached by the wrong person or service. That is why securing AI is not only about whether the model itself is safe. It is also about whether the full pathway around the model is controlled carefully enough to keep data from drifting into places it never should have reached. Beginners often imagine the risk begins and ends with the model, but the pathway is usually the larger story. The phrase data pathway helps because it forces you to think about flow instead of only about objects. A confidential file sitting in a protected folder raises one kind of security question. That same file being uploaded into an AI assistant, summarized into a chat response, copied into a shared workspace, and then forwarded into another business application raises a much broader set of questions. The risk changes as the data moves because each step may involve a different identity, a different trust boundary, a different retention rule, and a different audience. A system may have strong protection around where data is stored originally, but much weaker protection around how that data is used in prompts, temporary processing, output generation, or downstream automation. Security improves when teams stop asking only where the data lives and start asking how it travels, what transforms it undergoes, and which new systems or users can touch it after that movement begins. A pathway view turns invisible convenience into visible control decisions. This matters especially with AI because the value of the system often depends on gathering context from multiple places at once. A user may want the tool to summarize contracts, compare records, generate responses from internal knowledge, or assist with tickets by combining information from several systems in a way that feels smooth and efficient. That convenience is exactly what makes the pathway powerful, but it also makes the pathway dangerous if boundaries are weak. The more connected the AI environment becomes, the more important it is to know which sources it can reach, which data types it may ingest, whether all of those sources share the same sensitivity level, and whether the user asking for the answer should really be allowed to receive everything the system is capable of retrieving. An AI system can accidentally become a bridge between areas that were meant to remain separate. If its pathways are too broad, it may combine access, visibility, and output in ways that no single traditional application would have been allowed to do. Segmentation becomes one of the most useful protections because it helps keep those pathways from expanding into one large open trust space. In simple terms, segmentation means dividing systems, services, and data environments into smaller areas so that communication happens only where there is a real business reason for it. In an AI context, this can mean separating development resources from production data, keeping sensitive knowledge stores apart from general collaboration spaces, and making sure model services cannot freely reach every internal source just because someone thought broad access might be useful someday. Without segmentation, an AI tool may sit in a position where it can touch many unrelated data sets, receive requests from many kinds of users, and send outputs into many destinations with little friction. That may feel efficient, but it creates a very large blast radius if the system is misused, misconfigured, or compromised. Segmentation reduces that risk by making each connection more deliberate and easier to justify. A beginner should understand that segmentation in this case is not only about network diagrams. It is also about trust boundaries between users, applications, data sources, and operational stages. A team building an internal AI assistant may need one area where experimentation happens, another where approved models operate with controlled business data, and another where especially sensitive information is never exposed to general prompting at all. If those areas are not clearly separated, temporary testing practices may leak into production habits, and broad access granted during setup may remain long after the original need is gone. Segmentation can also apply to output destinations. An AI system that is allowed to read one category of data should not automatically be allowed to write results into every collaboration platform, ticket queue, customer record, or analytics dashboard in the enterprise. Good segmentation narrows both what the system can see and where the system can send information once it has processed that data. Zero Trust adds a second essential layer by changing how access decisions are made along the pathway. If a user has access to one application, that should not automatically mean the user can ask an AI service to retrieve or synthesize every related data source behind it. If an AI service was approved for one purpose, that should not automatically mean it can use the same identity and connectivity to perform very different actions elsewhere in the environment. Zero Trust thinking asks for verification and limitation at each meaningful step. Who is requesting this action? What specific data source is being touched? What device or service is making the request? What is the user's current role and business need? What action is being attempted? And does it fit the purpose this service was intended to support? This approach matters because AI systems can make access feel conversational and easy, which increases the temptation to forget that every apparently simple answer may depend on several very real trust decisions happening underneath. One of the biggest beginner mistakes is assuming that if a person is allowed to use an AI tool, then the tool may safely act as an all-purpose extension of that person across every connected system. That assumption is risky because the tool may retrieve, combine, transform, or present information in ways that go beyond what the person would normally see through ordinary application screens and workflows. A user might have legitimate access to one database for a narrow task and legitimate access to a document repository for another narrow task. But an AI assistant connected broadly to both might create a synthesized answer that reveals more than either system would have exposed in isolation. Zero Trust helps reduce this by treating each request with more precision. The system should not assume that prior access somewhere else is enough. It should check whether this user, through this service, for this purpose, should be allowed this specific combination of data and this specific output under the current conditions. Protected environments are the third major idea because some AI work should happen in spaces designed specifically to reduce exposure and keep sensitive data from leaking into less controlled settings. A protected environment is not merely a locked room in the physical sense, though physical security can matter. It is more broadly an environment with stronger controls around access, connectivity, storage, monitoring, and movement of information. In an AI context, this can mean running sensitive processing in a restricted part of the organization where only approved users, approved models, approved data sources, and approved output paths are permitted. The purpose is not to treat all AI as dangerous by default. The purpose is to recognize that some data and some use cases are sensitive enough that they deserve more than ordinary convenience settings. A protected environment creates a place where the organization can reduce unnecessary connections, restrict export paths, observe activity more closely, and keep model-assisted work aligned with stricter business, legal, or security expectations. Protected environments are especially valuable when the data involved is confidential, regulated, strategically important, or capable of causing serious harm if combined or disclosed improperly. Think about legal case material, sensitive human resources records, security investigations, product designs, customer financial information, or health-related details. In those cases, the risk is not only that someone might steal the raw files. The risk is also that an AI system might summarize them, connect them to other internal information, expose patterns to an overly broad audience, or make them easier to search and interpret than they were before. A protected environment reduces those risks by keeping the pathway shorter, narrower, and more observable. Instead of letting the data travel through a wide set of shared enterprise services, the organization can force it to remain inside a more controlled boundary where only specific inputs, outputs, identities, and administrative actions are allowed. That creates friction in the right places without preventing legitimate high-value work from happening. A practical example helps make these ideas feel more real. Imagine a company wants to use an AI assistant to help employees answer questions about internal policies, procedures, and project guidance. That use case may seem harmless at first, but the real security answer depends on what content the assistant can reach and who can ask what kinds of questions. If the assistant is connected broadly to every shared drive, archived conversation space, legal file area, and human resources repository, then a simple question about policy may become a pathway into far more sensitive content than intended. A segmented design would separate approved knowledge sources from unrelated sensitive repositories. Zero Trust would make sure that the requesting user and the assistant itself are authorized for the specific data involved. A protected environment might be used for especially sensitive policy or investigation material that should never be mixed into the general enterprise assistant at all. The result is not less useful AI. It is useful AI with boundaries that match real organizational risk. Another example involves automation after the model produces an answer. Many people focus only on what goes into an AI system, but the output pathway deserves equal attention. Suppose an AI tool summarizes customer messages and automatically writes results into a case management platform, sends a recommended response draft to an employee, and then stores the interaction for later analytics. If those downstream paths are too broad, the output may spread sensitive content, inaccurate conclusions, or internal-only context into places where it no longer belongs. Segmentation helps by separating which destinations are allowed to receive different classes of outputs. Zero Trust helps by verifying not just the reading of data, but also the writing or forwarding of results. A protected environment may be required when the source material or the output itself carries a higher level of sensitivity. This is a key beginner lesson because security failures in AI are not always about the model seeing too much. They are also about the model's outputs traveling too far, too easily, and into destinations that were never evaluated carefully enough. Several common misconceptions make this topic harder unless they are cleared away early. One misconception is that protecting AI means protecting the model alone, when the larger risk often lives in the surrounding data pathways, identities, and integrations. Another is that if the model runs inside the organization, then the whole pathway is automatically safe, even though overly broad internal connections can still expose sensitive information widely. Some people also assume that segmentation slows innovation, but uncontrolled connectivity usually creates bigger problems later by making it unclear what the system can touch and what damage a mistake might cause. Another misconception is that zero trust means users are distrusted personally, when the real point is that access should be verified and limited according to the current request and current need rather than granted broadly on assumption. Protected environments can also be misunderstood as extreme or unnecessary, but in reality they are often just a disciplined way to handle higher-risk data without banning valuable AI use cases entirely. The deeper reason all of this matters is that AI systems can compress distance between data sources, identities, and actions in ways older tools often did not. A user may feel like they are simply asking one question in one place, but underneath that moment the system may be touching multiple stores of information, applying transformation logic, creating new outputs, and sending those outputs onward to other systems or people. That compression of complexity is part of what makes AI attractive, but But it also means weak boundaries become more dangerous because the system can do a great deal quickly and quietly. Security, therefore, has to be designed around the pathway as a whole. Segmentation limits what can connect. Zero trust limits who and what is allowed at each step. Protected environments create stronger containers for work involving higher-risk data and higher-risk outcomes. Together, those ideas reduce the chance that convenience quietly outruns control. By the end of this discussion, the most important takeaway should feel straightforward even if the technology around it continues to change. Securing AI data pathways means understanding that the real risk is not only in the model itself, but in the full chain of movement that carries data into, through, and out of AI-assisted work. Segmentation helps keep sources, services, and destinations from blending into one large and risky trust space. Zero trust helps make access decisions more precise so that users and services receive only the reach required for the specific request at hand. Protected environments give organizations a stronger way to handle especially sensitive data and higher-impact use cases without exposing them to ordinary enterprise convenience paths. When those ideas are applied together, AI becomes easier to use responsibly because its data pathways are shorter, clearer, and more controlled. That is the real goal of secure architecture here, not fear of AI, but disciplined trust around how its power connects to the data that matters most.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.